The elite Aerosports Picaro 2.0 aircraft is moving along. Last video we finished the wings. This video we're moving into the cool stuff, which is getting the fuselage joined, the engine installed, the cool stuff in, all the organizing and awesome stuff. Thanks for tuning in. Let's dive into this aircraft. All right, last video we finished off with getting our wing wiring installed in the fuselage. And that is now routed forward to our equipment compartment. We're basically going to have all of the equipment installed in this area underneath the tray. So it's going to be a Bluetooth setup, completely invisible. When you look inside here, you'll see nothing, which is exactly how we like to do it. It's a pretty cool effect. So I'm pretty sure the next thing we need to do is think about joining our fuselage together. The engine's just sitting in there, it's not bolted in place. Unfortunately, you need to have the engine out when you screw this fuselage together. So getting the engine in is going to be a bit of a chore, but it's possible. So I think what we're going to do is we are ready to join this fuselage. I don't think we're going to bolt the engine down right away, and reason for that is we may need to tuck it back a little bit so we can get our intakes and everything installed. So one of the kind of important things that we did previously in the last video was get our engine and everything lined up. Our holes are already done, so essentially this engine is fit to the pipe is fit to the fuselage, and that's all ready to go. You don't want to be doing this and trying to get in this area with the engine installed. It's going to be really tough. That's ready to go. We'll just set the Chikoi 195 aside, and it is fuse bolting together time. So this is a great setup. We've got 4 locating pins. We've got 5 screws. Our leads are right here. Those are just tucked away while we were fitting the pipe and everything. And we are basically ready to go on this. So of course we're using lots of Loctite when we're putting this together, and it's never coming apart again in the future. All right, so we've got the fuselage bolted together, lots of Loctite used, and she's good. We have run all of our lines from the back end. They're kind of hidden nicely, so you won't even see them when all the equipment's installed. And then we've got them coming right to the front section right there. So that's all good. Next thing we need to focus on is going to be our fuel tanks. So I think when we put this plane together, we need to put the fuel tanks in, then maybe the engine, then the intake. So it's a bit of a puzzle to put this whole thing together, but regardless, we need to get our fuel tanks set up and ready to go. Now this is something you'd want to do anyways, because these fuel tanks come and the insides are just zip tied together. And I'll show you what I mean by that. So you've got zip ties holding everything together, and we're going to change the tubing out as well too, so, and just kind of revise how this thing is all done. But yeah, so we're going to get that done on all 3 tanks. All 3 tanks are essentially the same kind of setup. So the front tank, same type of thing. We've got the center rigid tube and whatever. So anyways, guys, we're going to get that done. Really nothing special with this. All of our vents and fittings and everything are already completed. So all we're really doing is rinsing out the tanks and redoing our lines to get these things ready to test. So we've rinsed our 3 tanks out with isopropyl alcohol. This is what I use to clean the tanks out. 99% isopropyl alcohol works great. You just dump it in the trash and it just evaporates. We've done the 2 main saddle tanks, redid the pickups for those. So I used a longer section of tubing, a little bit larger diameter tubing, and also used Viton tubing. Now this looks like Festo tubing, but the Viton tubing is more flexible. And then I also changed out the clunk lines as well. So this is the stock clunk, which is fine, but I use these guys. These are actually Skymaster ones, and they're just heavier, and they're going to allow this, this piece to move up and down properly. So anyways, those are redone, and we're going to do the front tank as well, basically doing the same thing. All right, so we just got everything kind of loosely placed in there. The point of doing this was to make sure, number one, that everything fit, and we know the process of getting everything in here. So first thing you need to put in is the engine. We've added our line to the engine because there's no access to the bottom of the engine. The engine gets put in, kind of tucked to the back as much as possible. So it is going to sit about an inch further forward than it's sitting right now. So what that means is our little center divider pieces in our intakes, those need to be sanded down. We need to sand out a little section for the front of the engine. Then, once the engine's in place, then you slip the side tanks in place. The side tanks need their bung fitting installed, so the pickup and clunk and everything needs to go in, so that's done. Center tank goes in, and then our intakes go in as well. So quite a process to get these things installed. None of it's bolted down, it's all just loosely placed in there. So I was getting an idea of exactly what we're going to do, kind of how we're going to run our lines and fuel lines and everything. So also got our UAT kind of just with one line hooked up. I'm not sure if I'm going to put the UAT here or up top. Now, some of the pictures on the website, they show like 2 batteries or 3 batteries in this area, not in the nose. So we will likely, because we're only using 1 battery in this plane, we'll likely put the UAT up here. I still might put it down there. Battery will probably go on top of the tray here, but we may put the battery in the front depending on how much nose weight we need. So those are all variable items that we need to play with. But next thing we need to do is take our intakes back out, and we're going to start to play around with our plumbing and intake installation and everything kind of from this point backwards. All right, so we got our 2 saddle tanks installed. We've got our center tank installed. And when I say installed, they're screwed down and fastened down. So those guys are done. We've put line on each of the outputs and inputs, depending on what it is, except our final vent lines, which are these 2 saddles here. So those 2 are going to come to 1 vent and then go outside of the fuselage. So what I'm doing here before I do anything else is I'm going to tie wire, safety wire, all of our fittings here. I've left all of these long, but they're all equal. So for example, the 2 coming off the saddle tank bungs or pickups, they're exactly the same. So when we get this all set up, if we cut 2 inches off this guy, we cut 2 inches off the other side, and they'll remain equal. So that's an important thing, of course. So I'm going to go through and safety wire all of those guys. Well, this plane is tight, Inez. We've got the intakes installed, that's done. Getting at these screws is definitely a challenge down there. Hard to show you, but I basically cut out about maybe 1.5 inches of the intake center portion, and it's just kind of rounded. Didn't have to go that far. I can stick my finger in between the turbine and the intakes. But we've got some decent space there anyways, so that's not a problem. It's actually kind of helpful because sometimes when you put these intakes in, you need to slide them this direction to get everything to clear, so I guess that is actually necessary. Hopefully we don't have to take these intakes out again because those are an absolute nightmare. Not much fun at all. I'm glad we got all the other stuff run, which is great. So I think the intakes are solid. I think I'm happy with them. Yeah, everything looks pretty solid. There's not a huge amount of contact here on the lip, like maybe, I don't know, a couple millimeters overlap there. And it should be fine though, I believe. So anyways, I think I'm pretty happy with this whole setup. It's definitely solid. These screws back here help get everything attached very well. And then as soon as you put the center bracket on, it just stiffens everything up. So I think that should be good, as that's the way it was designed. The next thing we get done is the plumbing, just because we're working our way forward. And I'm going to start to think about how we're going to lay things out in here. You know, probably fuel pump underneath here, our data relay module underneath here, and all of our other equipment underneath here. So it's going to be pretty tight in there because this isn't a lot of room, but yeah, I think I'm happy with that. We also need to start thinking about our front gear and our pitot tube as well too. We'll probably, once we get the plumbing done, we'll probably jump to the pitot tube and start working our way this direction and meet in the middle to get all the stuff installed in the center. All right, so we've got our tanks bolted in as I've talked about. We've plumbed everything. So if we follow this fuel path from the UAT. UAT sitting here, you fill the UAT up, it fills the center tank first. Tank fills, comes out of this line, splits at the T, goes to each of the saddle pickups. Saddles fill, come out the vents, that comes to the Festo Y fitting and out of the fuselage. Now I generally wouldn't use a Festo Y fitting or Festo fittings in the fuel system, but because this is on the vent line, I'm not concerned at all. And the other reason to have this here is if you have to take this stuff out, it's nice just to be able to pop the fittings off and not have to cut the lines and redo plumbing. So just having that is a pretty critical thing to make things easier to get these intakes out. The rest of the tanks can stay in place. You know, the saddles, the main tank, but if you need to get at anything, get the turbine out or whatever, getting the intakes out is the first step. So now our plumbing is done on the tanks. Next thing to move to, as I talked about, is the front of the aircraft. So we're going to get our pitot tube mounted in the nose. I'll talk a little bit about this. It's the same thing we do on basically every one of our planes that's getting a pitot tube. There's just going to be a little bit of that pitot tube sticking out. And the reason we do that is we don't use the atmospheric pressure on the pitot tube. We get it from inside the fuselage. So lots of people tell me that it doesn't work. It does work and it works great. We do it on so many different aircraft and it works perfectly. So we're going to get the M-speed sensor out and we'll work on getting that installed. Okay, so we got our pitot tube mounted. That's just stuck in place with some CA. I get the pitot tube installed from the back side, put a couple drops of thick CA and slip it into place. So as you can see here, we've only got maybe 3 or 4 millimeters sticking out. And then we will also put some high sol around this to make it a nice transition so it'll look basically invisible and then get painted black when it's done. So that's installed. The white line that comes out of the jetty pitot tube, which is the atmospheric line, those holes are about back where my thumbnail is. So those holes are obviously buried and we just take the white line right off. So there is just the red line coming back to the sensor. So next thing we're going to do is we're going to work on getting our front landing gear ready to go. We have to route this obviously, but we can get the gear installed as well too. So this plane becomes a little bit hard to see on the video, especially because the black internals, but we'll do our best here to keep things lit up for you. So let's take a look at our front landing gear. Okay, one of the things I really like about the Elite Aerosports aircraft is they're pretty much always using the same setup for the trunnion. They use this big long piece here, which is awesome, which and what that really equates to is getting the landing gear in and out of their aircraft is super simple. So they pretty much, as far as I've seen, not all of them, because I haven't built all of them, but pretty much all of them that I've worked with use this same setup. So landing gear slides in, big trunnion like that. I like that the gear comes up when it goes forward, which is awesome. One of the reasons I really like that is when you are flying this plane on a grass runway, the landing gear is down here, right in this area when it's down. And what that means is you're not kicking up a bunch of grass and stuff that gets sucked in the nose opening, which is awesome. The other landing gear on most planes or other planes where it comes like this, your front wheel's kicking up stuff and that gets generally sucked in to the nose intake. So what we do with the Electron gear is basically just like the mains. We're going to use Loctite on the servo mount here. That only goes on one way because you've got some recessed screws. And then our servo mount screws, your steering pin, Inez. Now the Electron front pins all come with these small flat spots. That small flat spot is designed for the steering arm. You do still need to flat spot the pin where your leg attaches to your pin. So we've got our landing gear bolted in. This is very straightforward to put in, so I just get it sitting in here, get my manual controller hooked up, get the wheel centered obviously, retract it, get it kind of nice and centered. The other thing you're looking for is this landing gear has the ability to move back a little bit further, and if you move it back, so this is touching this back wall, the leg will be hitting the fuselage right there. So I moved it forward a couple millimeters, and that allows the leg now to do its thing and operate and not interfere with anything. And then all I do is get it nice and centered by retracting this. So you can get the leg centered in the opening down there. And once I'm happy with it, I put one screw in, double check it, and then do the rest of the screws. But you can see there, it is perfect. There we go, awesome. So we'll do our servo plug-in for the steering servo right here. Obviously we've coiled that. So next thing I'm gonna do is I'm gonna get the M-speed sensor line run forward. All right, so we got our Cortex mounted, we got our fuel pump installed on a mount, and the mount screwed down to the sidewall. With the installs lately, this has kind of been my, my go-to area for those fuel pumps, and the data relay module kind of in this area right here, just to keep that length to the turbine as short as possible. Did have to put an extension cable on, so the stock cable comes to about here, and then I made an extension cable that reaches to the data relay module. It's only about 6 inches or so. Just added the Cortex onto one of our ABS / plywood plates. Have that high soled down. I made a square, sanded that down so we're exposing raw fiberglass, and we've got that high soled in place. Data relay module is going to go right there. Gear controller, we're going to install right in this area. This we're going to use double-sided Velcro. All the other stuff we're going to use Velcro. And the primary receiver, I'm going to install that right here, right beside the Cortex. And that's where I've decided to put that guy. And then we're going to have our SPEC 30 on this side, R3 for on-off, we can put wherever. And then our M-speed sensor is probably going to be sitting right in this area right there. So kind of have the general plan for everything. I think that's going to be good. I think the next thing I'm going to get done is get our UAT mounted on our top plate. I need to get that done because we got to let our Cortex cure, so I can't really do much in this area. So we're going to let that high sol do its thing. That's 5-minute high sol, so it'll set up pretty quickly. So I'm going to get the Flight Composite Tech UAT mounted to our board. So I did mark the board, which way's forward. And we do have to keep in mind when we're mounting stuff here that we do have, you know, these angled pieces. So when I put my UAT on here, I kind of want to keep it skewed right towards the center. So I was kind of thinking about putting it down there, but I'm pretty sure we're going to need the nose weight, so I'm going to get that mounted on the board, and I think that's going to be a good way to do things. I might even go middle of the board and just, the reason I would leave it back here like this is if we're going to put our battery in this area, that makes the single battery nice and simple. I think we're probably going to end up with the battery somewhere in the nose, but if we also mount the UAT here, then that eliminates our battery possibility. So pretty sure I'm going to mount that there. Our battery can sit in this area right here if need be, and then if need be, we can also mount the battery on one of those side pieces in the nose. But this would be ideal because super easy to access. All right, so we've got all of our equipment laid out now. Everything's mounted. I'll just go through it again here with you. So M-speed sensor, M-speed plugs into EXT port on SPEC. Turbine telemetry is also going to plug into EXT port, and then the EXT port from the SPEC goes into the receiver. That's why this is such a great device, because basically it acts as a splitter as well. So now we're going to get the telemetry of the SPEC, the M-speed, and the turbine all together. We've got our primary receiver mounted here, Cortex, gear controller, Chikoi, data relay module, and that is the basic equipment. The only thing left to put in here is our second receiver and our R3, which is our on-off. We can mount those in this area as well. So those are pretty generic and open as far as where we need to put them. So that stuff's done. Battery setup, I'm not worrying about right now. I'm going to start to get all of our leads done up that are going to the different devices. We've got a bunch of clips installed that'll allow us to keep our wires nice and clean. We've printed our labels here for our basic control functions, and we are going to start getting our wire ends done with our power box wire and power box connectors. All right, so we got all of our basic wiring completed for everything. We still haven't done any of our power yet, and I'll get to that. So everything's plugged in where it needs to go. There's no other leads that need to be run except some of our telemetry stuff. So at this point, we're still able to plug a battery into our receiver. We're able to plug a battery into our electron controller and drop the landing gear. So that's what I'm going to do here is I'm going to get the wings connected on the aircraft, and then we want to drop all of our landing gear. And what I'm planning on doing here is getting our tray installed and kind of getting everything roughed in, and then we will get our battery placement done. So the goal here is to get our battery mounted on this tray and achieve that CG point, the recommended CG point of the back of the tube. All right, guys, lots of time and time spent on wiring everything up. So everything is done with our basic setup here. We still have to mount our antennas, obviously, but our power system's all done, our primary receiver's done, our remote switch is done, our clone still needs to be mounted and sorted out, but I'm not worried about that. But right now this plane is engine runnable, surface movable, flyable type thing. So anyways, let's go over everything here and I'll show you what we ended up with. So starting from the front here, obviously we've got our plug-in for our steering servo. We've talked about that. This is our main battery input. Now we'll look at the tray and then we'll come back to this guy so you have an idea of what's going on. So this plane is powered with one battery to run everything. And yes, we've talked about it already a lot. It is controversial. Many people think it's a terrible idea. We have tons of planes out there set up like this. They fly amazing. They're being pushed harder than most people would ever fly their planes, and they're perfection. So let's take a look at the tray. So this is our main tray. We've got our UAT, obviously. This is pointing towards the back of the plane. Doesn't matter what orientation this is in. The only thing that matters is you get the air bubbles out when you fill the aircraft. Now the main tank on this plane, the vent's at the back of the front tank. So actually, regardless of whether you're filling this up or that first tank, the back of the plane needs to be lifted to get the air out of the UAT and that first tank. Our one battery goes in here. It's a 4,000 milliamp 3-cell LiPo. We've got our Velcro straps on there. This has been screwed down and we've sanded these screws off. We've marked it here 3-cell LiPo. We're also going to put 4,000 milliamps in a label inside here, but that just helps the owner to know what battery to put in there. And then we've got our GSU plug. This is for our turbine data screen ground support unit, and that's got a removable plug in case this tray needs to come out. Now this tray, if you undo this tray when it's installed in the aircraft, it does lift up and you've got great access to all of this stuff. So that's not going to be a problem. I'm also going to leave our lines a little bit longer, so conceivably this tray can come out quite easily. So power-wise, our main battery comes into this connector right here. There's a connector there just to keep this thing separate from the SBEC 30. If we hardwired into the SBEC 30, then switching this out would be a bit of a struggle. So that power lead comes over, goes into the SBEC 30, but it also splits off and goes to our turbine input, which is right there. So that is the LiPo itself. The 3-cell LiPo is supplying the SBEC with power and the turbine with power. 3-cell unregulated voltage. Coming out of the SBEC 30, our line comes to here, it splits. One lead goes to the Rex 12, the other side of this goes to the landing gear controller, which is right there. So that is the power system on here. It works so well. Trust me, it's amazing. It's not a first time we've done this. So that's basically it. This is our lead going to the tray for the GSU, which goes in there. That's teed off or Y-cabled. So one side goes into the data port and then the other side goes to our Chicoy telemetry unit, which plugs into our EXT1 port on our SPEC 30. So now when I turn this on, we're going to be able to see the SPEC 30 telemetry, the Chicoy turbine telemetry, and the M-speed sensor telemetry. So we are basically ready to turn this guy on for the first time. Pretty confident everything's going to work. Oh, we've also got our receiver there, our remote on-off switch. That plugs into the SPEC 30. So when you turn your radio on and flick your on-off switch, this tells this to turn on. When this turns on, it powers everything in the plane. All right, guys, so I just filled the fuel system up for the first time, filled the UAT, turned my system off, then started filling. So the UAT is not included in the system. So we've got 3.8 liters of fuel, 3,800 milliliters. So the front tank here is 800 milliliters. The two saddles are 3 liters, 3,000 milliliters in total. So the way this plane would work ideally, you're flying the main tanks, the 3 liters, and you're using your 800 milliliters for basically for landing. So when we CG this plane, we're going to CG it with some fuel in that smaller tank. That's kind of an important thing. You're always wanting to CG your plane in landing conditions. So gear down, UAT's full, whatever tank volume you're going to land with, that's what you want to have. Especially important if the tanks are well in front of the CG point. All right, so CG is spot on. Everything's looking fabulous. Good setup on this plane as well. So we've got about half of the front tank full. CG spot on. No canopy, but canopy's kind of splitting the difference anyways. And it's a decent amount of weight on the nose. The landing gear's about 3 inches behind the CG point, so it's a good balance on the aircraft. That's always something you look for. Some aircraft are really light on the nose, and it does make ground handling sometimes a little bit difficult. So that portion is done. So we're going to add some fuel back into the fuel system, and it's time to run this thing. And I did forget to mention that I added 2 strips of weight into the nose to get the CG spot on. Now it's highly likely that this weight will come out as the owner gets used to it and brings the CG back. Usually those numbers are a little bit conservative, but there's only 2 strips of weight in the nose. So that's 10, 20, 30, 40, 50, 60 grams. So that's 4 ounces of weight, I believe, 4-ish ounces of weight. And those are just tucked in the very tip of the nose there. All right, so before we do the turbine run, we've got to do some programming. So we've got our port right here for GSU. So we'll just plug the GSU in, which is good. And now we can turn on the aircraft and get our programming done.
Hello Magic, happy flying. Take off mode, half flaps.
So we're going to turn our aircraft on, flaps or gears down.
Receiver on.
Okay, so first thing we need to do is program the radio. So we're going to go into our radio, adjust, so stick up, trim up, stick down, trim down, stick down, trim up. There we go. So now we'll trim down to get it out of the ready condition. We'll go back into radio and adjust, no. So normal full expo, we don't want that. We want half expo, restart mode, auto. That part's done. We'll go into our start menu. Kerosene is correct. We'll leave all this stuff at its standard settings. We'll go into info. You can see 0 cycles on this thing because it hasn't been run yet. There we go, test our starter. Test glow plug, we won't bother. We want to prime our fuel system, so we'll prime it. Okay, so that's good. Test gas valve. I can hear it click. Test fuel valve. I can hear it click. There we go, and we'll go to our last screen, which is our run screen. And this tells us all of our settings. Fuel capacity, so we're going to bump this to 3.8 or 3,800 milliliters. Fuel calibration 0. There we go. So with those changes done, we are ready to run this engine. I'm going to add a little bit of our telemetry stuff to the radio screen just so we have it on there. So I'm going to get that stuff done and then we'll fire this guy up. All right, guys, we are getting ready to run this engine. So we're going to go through the normal procedures that we do here. So we're going to start the engine up. Hopefully it starts the first time. I don't think with the FCT UATs, because there's no bag on the filter, I don't think it's going to trap much or any air at all. But we'll let the idle stabilize. We will slowly go to full throttle and we will do some acceleration checks, a restart test, and that will basically be the test run of this engine. So as we work through this, I'll write up on the screen exactly what's happening. So let's start up this little hot rod. All right, guys, we got everything ready to go. I still have the data relay or the GSU screen hooked up so we can see what's going on. Trim up and initiate start. Now I can't see the line going to the back, so I don't know if it's got fuel all the way to the back, but we'll see. Oh, smells like it. Okay, we've got some air bubbles coming through the line. well, that was interesting. So one of the interesting things with this setup, of course, is we've got a very large engine with a plane that's designed for much smaller engines. So when I had the canopy on there and I was throttling up, at about half throttle, the canopy starts to suck in a little bit. So those are all things that you need to be very careful with, but also if we're mindful of this and we think about when the aircraft's in the air, we also have air getting rammed into the fuselage. So right now the airplane's static, it's not moving, there's no air moving into the intakes. When it's up in the air, you have air moving into the fuselage, so that is different. You could also feel a huge amount of suction inside the nose gear doors, so just something to be aware of. It's, yeah, gonna give it some thought. But test run went well. Everything works with the engine as it should. The restart was nice and quick. Acceleration's quick. Everything's good with it. So wicked combo. All right, so with test run done, now we're gonna get it back up on the stand and we'll do all of our surface adjustments on this aircraft. But before we do that, we'll do the flaps on the ground. I like to be able to visually see the flaps. Landing flaps, we know that they are set where they need to be, so that's fine, but we want to match up takeoff flaps and the off condition, no big deal, but visually is always the best for takeoff flaps so they're nice and even. All right, so we've got all of our surfaces and compensations and stuff set up sort of as per the manual. Like the ailerons call for 15 to 25 millimeters. I went with a 15, the 25 is going to be ridiculous. And yeah, so all the other stuff is set up as per the specified travels on the website. So now that we've got all of our travels going the right direction, all the offsets and everything proper, we need to take off our tray here. And number one, we need to goop all of our clips and connectors and everything. And number two, we need to also reprogram our Cortex. Now what I'm gonna do is I'm probably gonna run a lead just out to right here in this back area. So we're able to plug in a bind plug in the Cortex, sort of in this area, so it's hidden. We could add another port on the top here, but it's nice to have it as clean as possible. So pop the tray out and get that stuff done. All right, so we got all of our connectors gooped, and I realized that I had to do up one more connection here. So this connector here is two things. Number one, it's an extra power lead feeding the Cortex. And the other thing is it is a Y cable, so our second receiver can plug in to here. So basically this port goes to port A on the Cortex, and then the spare power lead goes to port 12, or it can go to any open port, but we're going to put it in port 12 of the primary receiver. And then when the owner gets the plane and sets the second receiver up as a clone, this patch lead here plugs into that right there. All right, so as a last step tonight, we're gonna add some additional cloth to the canopy. So we're doing one full strip on both sides of the canopy, and then we'll take one of these strips, cut them in half, and we'll do just a section in the center here. This is kind of the softest section of the canopy. So we're gonna mix up some West Systems epoxy, just some normal 105, 206 stuff, and get that installed tonight. When we do get this installed, one key thing when you're doing something like this is you want to get all the fiberglass work done. Obviously it's going to take a long time, hours for that stuff to cure. So you take this and you install it in the plane. The reason you install it in the plane is because maybe in the plane it sits like this out a little bit. So you want this to be sitting comfortably in the plane so it doesn't cure in a funny shape. All right, it is the next day and I'll show you what our canopy turned out like. Just sanded down the pitot tube. We put a little bit of Hysol on there yesterday and got that painted black. So it's nice and conformal now. So that is essentially invisible, and that's the way the pitot tube should look, especially on a sports jet. So canopy is much stiffer after that fiberglass is added. The sides of the canopy right here were like paper thin, which is fine for a normal size engine, but not for our 10G 300 mile an hour version. So I think I'm still going to add a brace on this canopy, I'm going to add 2 braces. The first one is going to be back in this area right here. And yeah, so right about this area where the green starts, or the front of the green. So we'll add one right there, and then we're going to add another one right in this area. As we get to the front, it's much stiffer in this whole front area, so we're going to put one right here, one right there. But yeah, it turned out really nice, happy with the result, and much stronger now. I was worried about that before. So we'll put a brace right in this area right here and right about there. So all I do for this is I just take some cardboard and kind of get a template made. Once the template's made, then we'll cut it out of appropriate material. One other consideration here is we've got the plane all CG'd with a 4,000 milliamp battery, none of the canopy additions done, so we'll have to recheck our CG on this plane because we've added more weight in the front portion of the aircraft. The owner also, his other planes that we fly with a single battery setup, we're using a 5,000 3-cell. I forgot about that, so we're gonna compensate for a slightly heavier battery. So we'll get that sorted out as well. All right, so we got our templates done. We transferred those to pieces of ply, and we have our aircraft ply cut out now. One of the important things if you're doing braces like this is you want them to fit loosely. So you don't want this brace to go in and alter the shape of the canopy. So both of our braces, same thing. They go in, they're loose, and we will tack them in place with some CA, and then we will glue them with some aero epoxy. So we're gonna add some lightning holes to these guys next. So we'll do that, and just to lighten the structure up a little bit, maybe 1-2 holes on this one or something. Anyways, I'm just gonna drill a bunch of holes in those guys, lighten them up, and then we'll get them fastened in place. All right, and there we go. She's all painted black and looking lovely. So this was totally one of those really good things to do on this, mainly because, again, we're going with the massive engine. So it is ridiculously stiff now on the canopy. So we should see a lot less suck in when this thing's at full throttle. So that feels better to me. Love that. So I'm going to re-CG this thing, and that is pretty much going to wrap up everything on this aircraft. All right, guys, and that wraps up the Picaro 2.0 aircraft. What a beautiful aircraft. I'm really excited to see how fast this thing goes, how rock solid it is. Great aircraft, whether you're putting a normal size power plant in it or overpowering it like we did. Again, to touch on this, all the additions and extras and stuff that we did in the shop here is only because we put way too big of an engine in the aircraft. So keep that in mind. If you are getting a Picaro 2.0 and you're putting a normal engine in it, none of that stuff is necessary. So thanks guys so much for tuning in to the video series. Also want to give a shout out to channel members. Thank you, channel members, for being channel members. I appreciate your support a ton. If you're watching this and you're wondering what a channel member is, well, you can check the links down below on the actual channel on YouTube. And if you become a channel member, you get access to all of our videos a couple weeks early. So we often have 1 to 2 weeks of videos uploaded to YouTube, and channel members get early access to those videos. So thank you, channel members. Thank you everybody for watching, and we'll see you in the next video.